Hi there, it's Reid, your math and test prep tutor. Today I wanted to look at a math problem from the calculator section of Practice Test 6 from the College Board SAT practice tests. I picked this one because it's a little unusual. You likely wouldn't have seen it on any of your math homework. So let's get started. Here's the problem we'll be looking at, number 26. So pause the video here to take time to read the text and view the figure. Be aware of all of the information that's provided. So in this case, there's text in the beginning, followed by a figure, followed by more text, which is where we find what they're asking. So let's take a look at exactly what they're asking for. The number of revolutions per minute for gear C. Now let's also identify the information given to us. So gear A is rotating at 100 revolutions per minute, and they also give us the figure. So there are two basic starting points here. First, there's more of a numerical approach, and second, there's more of a visual approach. I'm actually going to start with the second approach, the visual approach, and we'll work our way back around to the more numerical approach. So let's think about one full turn of gear A. We'll just draw a turn there. How much does that turn gear B? Is it one full turn of B? No, not really. It's probably not even half a turn, and that's because gear B is so much larger than gear A. Now what about B and C? For one full turn of B, how many times does gear C turn? So let's actually just draw gear B turning. Notice that's a large gear. So gear C is probably turning many, many times. So we have some sort of relationship here. We would expect gear A to turn B not a lot, but B to turn C many, many times. But the question asks about gear C in relation to gear A. So let's see if we can figure that out. Gear A is larger than gear C, so we would expect that one turn of A would give several turns of gear C. Note here that we can already eliminate the answer choice A because that's saying gear C has 50 RPMs when gear A has 100. And that is wrong because gear C should have a higher number of revolutions per minute. There's actually a key observation that makes this easier, and maybe you've already noticed it. If you imagine gear A directly turning gear C, it's still the same problem. If you saw this earlier, good job, and if not, don't worry. It just means now we can ignore B altogether. We're just looking at the relationship between gear A and gear C. See how much work we did using just the figure? Now we only need to look at gear A and gear C, and that cuts our computations down by a lot. So, in one revolution, gear A turns 20 teeth. We get that information from the figure. Now since the teeth interlock, one turn of gear A turns 20 teeth of gear C. So I'm talking about teeth and not revolutions. So if we've turned 20 teeth and gear C has only 10 teeth, that means that we have 2 revolutions for C than we did for A, which we started off by saying had 1 revolution of 20 teeth. We have one more step to go. So the problem gave us that gear A was going at 100 RPM, and we now know that gear C is going twice that, so the answer is C, 200 RPM for gear C. Good work. Another approach is using numbers. In the first approach, we ignored the information in the first paragraph. But here let's actually take a closer look. The ratio of the number of revolutions per minute, or RPM, of two gear wheels is S to R. That's a ratio, but we can also think of it as a fraction. We just need to figure out what S and R are referring to, and that actually comes from the first sentence. It's the ratio of the number of teeth of two connected gears. Only in the first sentence it says R to S, and then the second sentence S to R. So let's just write that out. Gear ratio, and I said I would write it as a fraction, and ratio of RPM is S over R. R and S came from the number of teeth, so we just need to identify the number of teeth of the gears we're looking at. I'm going to borrow from our first approach and say that we can actually ignore gear B because gear A will turn the same number of teeth in B as B will then turn in C, meaning what happens to B will also happen to C in terms of the number of teeth. This is great because our ratios only use the number of teeth. That's actually a bit of a mouthful, so I hope I'm making sense here. I want the gear ratio of A and C. So R will be the number of teeth in A, and S will be the number of teeth in C. And since this is a fraction, we can reduce it to 2 over 1. But we're not interested in the gear ratio to answer the question. We need the RPM ratio. So what's the relationship between the general formula? They just flipped over. So we'll do that with A and C. We just flip these over, and we'll get we'll get 1 over 2. Now the last step is to actually get the value of the RPM for gear C. We just have the ratio, and we can use a proportion to find the actual value. So I'll take this 1/2, and I'll set it equal to another ratio. Now since I'm finding the RPM for gear X, gear C rather, let's call that X. So C was on the bottom, I'll put X here, and we were already given 100 RPM for gear A in the problem. So let's just write in 100. So let me just scroll down a little bit and we'll just solve for X. Actually, I'll use the space to the right. When we have a proportion like this, we would just cross multiply. So we would do X times 1 and 2 times 100. So here, we'll get on the left, let me just change the color, X times 1, which we don't have to write, and 2 times 100, which is 200, so therefore our answer is C, 200. So let's recap. We went through this problem with two different approaches. First, starting with the figure and using the size of the gears, and the second one using the ratios and plugging in the numbers to solve for a variable that we named. There are a few other approaches as well, so if you solve this problem in a different way, good work! You'll need the skills in this problem to tackle many other problems that may come up on the SAT. These skills include figuring out problems based on the figures, working with unfamiliar units such as the number of teeth or the number of RPM, and comfortably handling ratios and proportions. Thanks for watching this video. There's a lot more information to cover, including different types of problems, goal setting, test-taking strategies, and more, so definitely stay tuned. I'm currently based in Pensacola, Florida, and I am available for one-on-one and group tutoring. I'll be releasing online tutoring in the future, so keep an eye out for that. Happy studying!